So we will be solving May-June 2022 question paper 12. The first question, which estimate is reasonable? Now, the first option says 1 into 10 to the power minus 3 kilogram for the mass of a grain of sand. So 1 into 10 to the power minus 3 kilograms is actually 1 grams. Do you think that the mass of a grain of sand would be 1 grams? 1 gram is approximately the mass of, I would say, a paperclip. A paperclip has a mass of 1 gram. So sand is obviously way lighter than a paperclip. So it cannot be 1 into 10 to the power minus 3 kilograms. Or if you've ever done any experiment in the lab which involves dry chemical, that would also give you a good idea of how much 1 gram is, which is way more than the mass of a grain of sand. Then the next part says 1 into 10 to the power minus 2 meter cube for the volume of a tennis ball. For the volume of a tennis ball. Is my voice better now? So what is the formula for volume? Volume is equals to 4 over 3 pi r cubed. So 4 upon 3 pi. What do you think is the diameter of a tennis ball? Because if you were to estimate the diameter of a tennis ball, this is roughly the size of a tennis ball. If you have a ruler in front of you, just place your ruler, give me an estimate of the diameter of a tennis ball, and you would realize that it's somewhere around 6 to 8 centimeters. So 6 to 8 centimeters. And let's say it's 7 centimeters. So 4 upon 3 multiplied by pi into the radius being 7 divided by 2 and also divided by 100 to convert centimeters into meters. The entire thing cube. And that gives you a rough value of 1.8 into 10 to the power minus 4 meter cube. And this here says 1 into 10 to the power minus 2, which is 100 times greater, which means this is an incorrect estimate. C says 1 joule of 1 into 10 to the power 0 is actually 1 joule of work done lifting an apple from waist height to the waist height to head height. So waist height to head height would approximately be around 1 meters or less, depending on how tall you are. But take any value as a reasonable estimate. And what is the mass of an apple? I believe the mass of an apple would be around 200 grams. So mgh, let's say the mass of an apple is 200 grams. The value for g, let's take that as 10. And the height, even though it would be less than 1 meter, but let's take it as 1 meter from waist to head height, or let's take it as 0.8 meters, 0.8. If you think that's a fair estimate for the height from the waist to the head. So 200, which is divided by 1000 to convert grams into kilograms, 200 upon 1000. So 0.2 multiplied by 10 into 0.8, and that gives you around 1.6 joules. And it says 1 joule. So I believe this is a reasonable estimate for the work done to lift an apple from waist height to head height. Question D says, part D says, option D says, 1 into 10 to the power 4 watts for the power of a light bulb in the house. So the power of a light bulb in the house is approximately 60 to 70 watts. And 1 into 10 to the power 4 is obviously 1, 0, 0, 0, and 0. 4 zeros, which is way greater than 60, 70 watts. Or even if you use the older filament bulbs, then I believe they have a maximum power of around 100 watts, 110 watts. So a reasonable estimate is C, the work done in lifting the apple. Question 2 says, what is the symbol for the SI base units of temperature? So temperature is measured in Kelvin. The SI base unit is Kelvin. And the answer is B. It's not degree Kelvin. It's just Kelvin. 3 says, which statement about systematic errors is not correct? A systematic error can be caused by using an incorrectly calibrated instrument. Yes, incorrect calibration leads to systematic error. This is correct. One particular type of systematic error can affect all the measurements by the same amount. Agreed. So if you have, let's say, an error of a particular type, that would affect all the measurements by the same amount. That is the property of a systematic error. The effect of a systematic error can be reduced by repeating and averaging the measurements. No, this is not correct, and hence the answer. Random errors can be reduced by repeating and averaging. Systematic errors cannot be reduced by repeating and averaging. Zero error is a type of systematic error. Yes, zero error is a type of systematic error. So this is not the answer. So that was question number 3. Question 4. Question 4 says an object is moving with an initial velocity of 4 meters per second to the right. The velocity of the object changes so that its final velocity is 3 meters per second downwards as shown. Which arrow represents the change in velocity of the object? Change in velocity of the object. So what is the formula for the change in velocity? It's final minus initial. Final velocity minus initial velocity, which can also be written as final plus minus initial, which means that I'm adding the two, but initial is actually is a negative value. So if this is plus initial velocity, if I were to represent minus initial velocity, that would be represented by an arrow in the opposite direction. And this is my final velocity downwards. So I have my final velocity in the downwards direction. I have my negative initial velocity to the left. What do I need to do next? Final plus minus initial, and that gives you the resultant. So this is the direction of our resultant R, which is represented by option B here. Is this clear? Any questions? Can I repeat? Yes. देखो क्वेश्चन आपसे क्या कह रहा है? क्वेश्चन आपसे कह रहा है which arrow represents the change in velocity? Why did you take why not A? अच्छा जी, देखो यहाँ पर जो हमें है ना चेंज चाहिए, यहाँ पर हमें चेंज इन वेलोसिटी चाहिए. चेंज इन वेलोसिटी इज फाइनल माइनस इनिशियल. you're not adding the two up, you're subtracting the two. सही. तो फाइनल माइनस इनिशियल का मतलब हो गया कि फाइनल प्लस नेगेटिव इनिशियल. दैट इज व्हाट इट मींस. फाइनल प्लस नेगेटिव इनिशियल. So that is why I changed the direction. So I'm actually adding the two, but I've taken the negative vector of the initial velocity. So instead of taking plus 4, I've taken minus 4 meters per second. And then I've said final plus minus initial, or 5, and this is, 3, and then this is minus 4. And the resultant is always from the head of the first one to the tail of the last one. That is why you get option B as the answer. Question number 5 says a car travels anti-clockwise along a horizontal circular road of radius 12 meters as shown. The car takes a time of 4 seconds to move from position P to position Q. What is the magnitude of the average velocity of the car from the journey from P to Q? So starting from P and ending at Q, even though this is the path of the car, this is the direction of travel, but it does not make a difference what the direction of travel is. For us to find out average velocity, it is displacement upon time. So starting from P, ending at Q, irrespective of the path, this is the displacement. And how do I find this out? This is under root 12 squared plus 12 squared, Pythagoras' theorem. And that gives me the answer as 16.97 meters. It's a right angle triangle. You use hypotenuse squared is equal to perpendicular squared plus base squared, and that gives you 16.97. So 16.97 upon the total time, which is 4 seconds. And that gives you the answer as 4.2. What is the difference between velocity and average velocity? So velocity is a general term. Initial velocity is velocity. Final velocity is velocity. Average velocity is velocity. Okay. Velocity की जब वो बात करते हैं, you can have instantaneous velocity. Instantaneous is that for a car moving, कभी उसकी velocity ज़्यादा होगी, कभी उसकी कम होगी. Instantaneous velocity is at any instant. What is the velocity? Average velocity is for the total journey. What is one value of velocity that would give the same, cover the same displacement in the same time? That is what average velocity is. Question number 6 is, why not considering the circumference, the smaller sector? Because displacement is always in a straight line. That is why we're not taking this curved path. Question number 6 says the water surface in a deep well is 78 meters below the top of the well. A person at the top of the well drops a heavy stone down the well. So what's happening is you've got a well here, you've got a well here. A person drops a stone. So this is a stone. And this well is 78 meters deep. This is 78 meters deep. What is the time interval between the person dropping the stone and hearing it hit the water? So let's first find out how long does it take for the stone to reach the bottom of the well. S is equals to ut plus half at squared. S is equals to ut plus half at squared. Hence, S, which is displacement, which is 78, is equals to initial velocity 0 plus half into 9.81 into t squared. सही. तो आपके पास क्या हो गया? आपके पास t की वैल्यू आ गई 3.99. You work this out, you get t is equals to 3.99. ठीक है? A lot of students would say कि जी we've got 3.99, the answer should be B. But you are forgetting that this is the time it takes for the stone to come down. And the question says, what is the time interval between the person dropping the stone and hearing it hit the water? So your sound needs to travel up now. So for sound, speed is equal to distance upon time. Time is equal to distance upon speed. The total distance is 78. The speed of sound is 330. And that is basically 0.23 seconds. So the time it takes for the stone to come down is 3.99. The time it takes for sound to travel upwards is 0.23. The total time is 3.99 plus 0.23, which is equals to 4.22 seconds. So the total time is 4.22 seconds. No, time interval is the time difference between the point where they drop the stone and hearing it. See, that is what they mean by time interval. So you add the two up. Question 7 says, which statement is not a requirement of a pair of forces that obey Newton's third law of motion? The forces act in opposite direction. That is a requirement. The forces act on different objects. That is a requirement. The forces act on objects in contact, not necessary. Even if they're not in contact, the force may act. Like two magnets attracting each other, opposite charges attracting each other. Gravity between the sun and the earth, gravitational force. That also follows Newton's third law, and they're not in contact for sure. So this is not a requirement. The forces are of equal magnitude. That is definitely a requirement. Question number 8. Question 8 says, a child of mass 20 kilograms stands on the rough surface of a sledge of mass 40 kilograms. The sledge can slide on a horizontal frictionless surface. One end of the rope is attached to the sledge. The rope passes around a fixed frictionless pole, and the other end of the rope is held by a child as shown. The rope is horizontal. The child pulls the rope, pulls on the rope with a horizontal force of 12 newtons. This causes the child and the sledge to move with equal acceleration towards the pole. So the child and the sledge both have an equal acceleration to the right. Equal acceleration. Now, as far as the total system is concerned, as far as the child and the sledge is concerned, the total force that the child and the sledge experience is 12 newtons. 12 newtons. So I can say F is equals to ma for the child plus the sledge. The total force that the two experience is 12 newtons according to Newton's third law. The total mass is 60 and the acceleration is a, which means a is equals to 0.2 meters per second square. As far as the child is concerned, how does the child move forward, or why does the child move forward? The child moves forward because of the friction between the child and the sledge. So the sledge slides forward, and the friction between the child and the sledge is what basically drags the child forward. And that's the only force acting on the child. If you were to look at the child alone, the only force that drags the child forward is the friction. So for the child, I can say F is equals to ma once again. The force on the child is an unknown force, and I know that is friction. The mass of the child is 20, and the acceleration stays the same irrespective of whether you're talking about the entire system, the child and the sledge, or the child. So the acceleration is 0.2 meters per second squared. And that gives you 4 Newton. So what is the frictional force between the child and the sledge? It's 4 newtons, right? Or you could have also said that the total force on these two is 12 newtons when the total mass is 60. The mass of the child is 1/3. So obviously the force on the child will also be 1/3 because their acceleration is constant. That was question number 8. Question 9 says a stone S and a foam rubber ball are identical spheres of equal volume. They are released from rest at t is equals to 0 and fall vertically through air. Both reach terminal velocity. Which graph best shows the variation with time t of the speed v of the stone and the rubber? So for the stone and for the rubber, one thing that they've told us that they both reach terminal velocity. Because the foam rubber ball will be lighter as opposed to the stone, it will have a lower terminal velocity. वो जल्दी terminal velocity पे पहुंचेगा और छोटी value पे terminal velocity पे पहुंच जाएगा, as opposed to the stone. Hence, the answer can only be B. With the rubber ball having a lesser terminal velocity than the stone. Sorry, the answer is B. That is similar to what happens if you were to throw a bowling ball in a path and a feather. See, for a bowling ball and a feather, even though they don't have the same volume and everything, but if you had, let's say, a bag full of feather, the same size as a bowling ball, because the bag full of feather has a lesser mass, it will reach terminal velocity earlier at a lower value. ठीक है, उसका वेट जो है वो एयर रेजिस्टेंस से इक्वल पहले हो जाएगा बिफोर द bowling ball. So the answer to 9 is B. Question number 10 says, two balls X and Y are moving towards each other with speeds of 5 meters per second and 15 meters per second respectively. They make a perfectly elastic head-on collision and ball Y moves to the right with a speed of 7 meters per second. What is the speed and the direction of the ball X after the collision? So I don't know their masses, but I do know that it's a perfectly elastic collision. So for an elastic collision, I can use the equation relative velocity of approach is equal to relative velocity of separation. U1 minus U2 is equal to V2 minus V1. U1 is 5, U2 is minus 15 because this is to the right and this is to the left. So this has to be negative, minus 15. Ball after collision, ball Y moves to the right with a speed of 7. So after collision, ball Y moves to the right with a speed of 7, which means V2 is 7. This is V2. And V1 is unknown. And this gives you 20 is equals to 7 minus V1. V1 is equals to minus 30, which means that after collision, this ball X travels to the left with a speed of 13 meters per second. 13 meters per second to the left. And how do I know it's to the left? Because of this negative sign. Question 11 says two forces form a couple. Which statement describes the two forces? If they're in the same direction, no. Couples are always in the opposite direction. They're perpendicular to each other, no. Couples are always parallel to each other. They have the same magnitude. Yes. Equal, opposite. They pass through the same point. No. They're parallel, hence cannot pass through the same point. So 11 is C. Moving on to question number 12. Question 12 says a uniform rod is attached by a hinge at one end to a wall. The other end of the rod is supported by a wire so that the rod is horizontal and in equilibrium. Which arrow shows the direction of the force on the rod from the hinge? So at this point, what is the direction of force on the rod from this hinge? So let's mark the forces. We've got our weight downwards and we've got our tension in this direction, upwards. Now, one thing that you need to understand is for cases like these, where you have three forces acting in this manner, if the system is in equilibrium, all the three forces need to pass through the same point. If you were to extend these forces, they'll meet at a single point. So let's extend the arrow for weight. So this is weight somewhere here. And then we have tension. So the force from the hinge on the rod should also act in such a way that it passes through this point that you see, which is option D. All good? Can you please explain this again? Sure. For an object in equilibrium, for three forces like these, it is necessary that all three forces pass through a single point. So we have our weight acting in this direction, vertically downwards, vertically downwards. I've extended the line of the weight. My force from the hinge on this rod should also act in such a way that it passes through the same point, so that you end up with all three of the forces passing through a single point. And the reason behind that is pretty simple. The reason behind that is because the net moment is zero. So if I were to take this as the pivot, and because all three forces pass through this point, through this pivot, the net moment definitely will be zero. Question number 13 says a diving board of length 5 meters is hinged at one end and supported 2 meters from this end by a spring of spring constant 10,000 newtons per meters. A child of mass 40 kilograms stands at the far end of the board. What is the extra compression of the spring caused by the child standing on the end of the board? So this child causes anti-clockwise movement about this hinge. And the spring causes clockwise movement. And it's balanced. So the clockwise is equals to the anti-clockwise moment, which means that 40 into 9.81, which is the weight, multiplied by this total distance, which is 5 meters from the pivot. Distance from the pivot is 5 meters. It is 5 meters is equals to force. This is the force F exerted by the spring on this board multiplied by distance, which is 2 meters. And that gives you the value of F as 981 newtons. So the force F is 981 Newton. The question says, what is the extension? So extension is equals to force upon spring constant. The force is 981. The spring constant is 10 kilonewtons per meter, hence 10,000 newtons per meter. And that gives you 0.0981 meters, which is 9.81 centimeters. So the answer is C. Why is the spring clockwise? Because the spring exerts an upward force. And with respect to this hinge here, this upward force can only make it go in this direction. The spring is getting compressed, so how can it exert a force? The spring is getting compressed. That is why it's exerting a force. Because the question is is the answer. If you compress a spring, it exerts an equal and opposite force. That is why when you release it, it goes back to its original site. So shouldn't we include the force exerted on the spring by the board when taking movement? So on the spring by the... No, not the force exerted on the spring by the board. We need to take into consideration the force exerted by the spring on the board. जो फोर्स स्प्रिंग बोर्ड पे लगा रही है क्योंकि मोमेंट इस बोर्ड के लिए ना, ठीक है, तो एक्शन रिएक्शन पेयर है, ठीक है, and this exerts an upward force and that makes it go in this direction clockwise about this hinge. Question number 14 says, a granite rock at the surface of the earth has a density rho. The rock is transported to the surface of another planet. The acceleration of free fall on the other planet is twice that on the surface of the earth. What is the density of the rock on the other planet? The formula for density is mass per unit volume. Irrespective of the planet, the mass stays constant. Irrespective of the planet, the volume stays constant. Hence, the density stays constant. So if the density was rho on the surface of the earth, the density will be rho on the surface of this other planet. It's common sense, yes. Moving on to question number 15. Question 15 says a closed U-shaped tube contains a stationary liquid of density rho. One side of the tube contains a gas at pressure P1 and the other side contains a gas at pressure P2 as shown. The acceleration of free fall is g. Which equation is correct? Now, you can't go through all these equations and figure out which one is correct. The easier approach to this is you make the equation yourself. So I know that for a continuous liquid at the same level, the pressure will be same. So the pressure over here, and I can say this pressure is equals to P1. That's it. The pressure at this point is this due to this gas, which is P1. There's no liquid above it. Will be equal to the pressure over here. Let's call this P. P is equals to P2. P2 is the pressure due to this gas plus this height of liquid, What is this height of liquid? Can anybody tell me? What height of liquid is this? Y minus Z. Y minus Z. Perfect. So P2 plus rho G Y minus Z. And since I know this pressure is equals to this pressure, I can equate the two and I get P1 is equals to P2 plus rho G Y minus Z. And hence P1 minus P2 is equals to rho G Y minus Z. And I can see that is option C. P1 minus P2 is equals to rho G Y minus. Question 16 says, which product of two quantities is equal to power? Power is basically force into velocity. That's a formula for power. Power is equals to Fv. So the answer is B. Force into distance is work done. Work done into time. I don't think that represents anything. Work done into velocity. No. Question number 17 says, researchers have developed a new type of filament lamp with an efficiency of 40%. Old type filament lamps have an efficiency of 5%. The two types of lamp produce the same useful output power. What is the ratio of the input power of the new type of lamp to the input power of the old type of lamp? So I know input of the new lamp, let's call that Pn. And since it's 40% efficient multiplied by 40 upon 100 is equals to the output power. And this is for the new lamp. So I can write this as P out into 100 divided by 40, 2.5. I can write it as P out, P in, sorry, is equals to 2.5 times P out. And this is for the new type of lamp, new lamp. So I have an equation for input power. Similarly, for the old type of lamp, which was only 5% efficient, P in multiplied by 5 upon 100 is equals to P out. Which means P in is equals to 20 times P out. P in is equals to 20 times P out. P in is equals to 20 times P out. Now the question says, what is the input power to the new type of lamp to the input power ratio of the input power to the old type of lamp? How do I get 2.5? This is 40 upon 100, no? You shift it to the other side, this becomes 100 upon 40. 100 upon 40 is 2.5. Similarly, this is 5 upon 100. You shift it to the other side, Mohib. This becomes 100 upon 5. Okay. Now I need to find out the ratios. So the ratio of the new type of lamp is 2.5 P out upon 20 P out. And because the output power is same, this P out cancels out with this P out. You're left with 2.5 upon 20, which is 0.125, which is 0.13. So the answer is A, 0.13. I hope this is clear. Question 18 says, a student attempts to derive the formula for kinetic energy. She begins by considering an object of mass m, which is initially at rest. A constant force F applied to the object causes it to accelerate to final velocity v in the displacement s. The kinetic energy gained by the object is equal to the work done on the object by the force F. Which equation would the student not need in order to derive the formula for kinetic energy? Now, which equation will the student not need? So let's derive the formula. He begins by considering an object of mass m, which is initially at rest. A constant force F applied to the object causes it to accelerate. So work done, kinetic energy is equals to work done. And we know work done is equals to force into displacement. So do I need force into displacement? Yes, I do. And force is equals to mass times acceleration into displacement. So have I used the equation F is equals to ma? Yes, I have. Then to replace acceleration, I need to get rid of acceleration. So I know v squared is equals to u squared plus 2as. So I can say as is equals to v squared minus u squared upon 2. So m times v squared minus u squared upon 2. And that gives you half mv squared minus u squared. So I have the equation for kinetic energy, and with what have I not used? I haven't used energy is equals to half Fs, which some of you would figure out directly without feeling the need to go through this entire process. But even if you go through this entire process, you realize that you don't use option C, the equation in option C. Question 19 says a metal wire obeys Hooke's law and has a Young modulus of 2 into 10 to the power 11 pascals. The wire has an original length of 1.6 meters and a diameter of 0.48 into 10 to the power minus 3 meters. What is the spring constant of the wire? So I know Young modulus is force times length upon area times extension. And force per unit extension is spring constant. So I can replace this with Young modulus is spring constant times length upon area. And hence, spring constant is Young modulus multiplied by the area divided by the length. Once I have this equation, the only thing I need to do is substitute the values given in the question. So the Young modulus is given as 2 into 10 to the power 11. The area is pi d squared. They've given us a diameter, hence area is equals to pi d squared upon 4. Or you can divide the diameter by 2 and get the radius upon 4 divided by the length, which is 1.6. So I have the Young modulus, I have the area, I have the length. Solving gives me the spring constant, which is 22619, which is equal to 2.3 into 10 to the power 4 newtons per meter. The answer, therefore, is B. Question 20 says, a wire is being stretched by a tensile force. Which statement about the elastic limit must be correct? The deformation is plastic after the elastic limit has been reached. Yes. Up till the elastic limit, it's elastic deformation. Beyond the elastic limits, it's plastic deformation. So A is correct. The deformation is plastic until the elastic limit. No, that's elastic deformation. Until the elastic limit, you have elastic deformation. The extension is proportional to the tensile force after the elastic limit has been reached. No, this is before the limit of proportionality. The extension is proportional to the tensile force until the elastic limit is reached. No, it's until the limit of proportionality. If you were to look at the graph, you have a straight line initially up till the limit of proportionality. Let's label that P. And then you have the elastic limit somewhere over here. And then you have the plastic region or the plastic deformation after the elastic limit. So force is directly proportional to extension up till this point. 21 says, which statement is correct for all types of progressive waves? The distance from a peak to the next trough is equal to one wavelength. So peak to trough is half a wavelength, not one wavelength. They can be demonstrated in ripple tanks. Only water waves can be demonstrated in ripple tanks, not electromagnetic waves, which are also progressive waves. They consist of vibrating atoms. No. Electromagnetic waves are basically electric field and magnetic fields that are oscillating. They don't have atoms. They transfer energy from one position to another. Yes, that is the definition of progressive. They transfer energy. Now, this is an interesting one. 22. A transverse water wave is moving along the surface of some water. This causes the ball to move vertically without moving horizontally. So the ball moves vertically. The ball moves down, reaches the lowest point, and then back up, and so on and so forth. This is the path of the ball. The wave has a frequency of 0.2 hertz and an amplitude of 0.7 meters. The distance between a trough and an adjacent peak is 2.4 meters. So from this trough to this peak, it's 2.4 meters. This amplitude is 0.7. What is the distance traveled by that ball in terms of in a time of 20 seconds? So let's first find out how many time periods is 20 seconds. So F is equals to time period is equals to 1 upon frequency and 1 upon 0.2, which is equals to 5 seconds. So the time period of this wave is 5 seconds, which means in a total time of 20 seconds, you will have 4 time periods. So if the ball starts off at the crest, it will end up at the crest, but after 4 complete time periods. Now, the second thing is figuring out how much does the ball travel in one time period. In one time period, the ball that starts off at the crest goes to the trough downwards and comes back to the crest. And if this is 0.7 meters, this is 0.7, then 0.7, 0.7, and 0.7. So the ball travels a total of 0.7 into 4, which is 2.8 meters. The ball travels 2.8 meters in one time period. How much does it travel in? 4 time periods. So 2.8 multiplied by 4, which is equals to 11.2. So the ball travels a total distance of 11.2 meters in 4 time periods. There, I'll go over this again. The first step in this question was figuring out the time period of the wave. We had the frequency. Time period is 1 upon frequency, and that gives you 5 seconds. The second step was figuring out how many time periods is 20 seconds. And if one time period is 5 seconds, 20 seconds is exactly 4 time periods. So we are past that point. The next thing, this 2.4 meters, this part is given just for confusion. You don't need to use this. The next thing is I figured out that when in one time period, the ball travels down, which is 0.7, and then further down to the trough, which is also 0.7, and then back up, which is 0.7 plus 0.7 again. So the ball travels a total of 2.8 meters every time period. And since it's 4 time periods, it's 4 times 2.8. ठीक है, 4 दफा ऐसी जर्नी कंप्लीट करेगा. Can we do it like one wave is equal to 5 seconds? So how many waves will be completed in 20 and then half wavelength is 2.4? No, you can't, you don't need to use this wavelength. This is irrelevant to the entire question. The reason behind that is that the object is moving, the ball is moving up and down and not forward and backwards. Even the question specifies it. The ball moves vertically without moving horizontally. I hope this is clear. Question number 23 says, a sound wave travels from left to right across a room. The variation with distance across the room of the displacement of the air molecule at one instance is shown. At which distance will the air pressure be lowest? Okay. So let's work it out. At point A, the particles are to the right. The particles are to the right. At point B, the particles are not moving. At point C, the particles are to the left. At point D, once again, the particles are not moving. They're at the mean position. The displacement is 0. And at this point, the particles are to the right. Now, if you were to compare these points, you would realize that at point B, the pressure will be highest. The reason behind that is these particles are to the right, these particles are to the left. So they're basically compressing this point. This is a region of compression. At point D, the pressure will be, B पर compression होगा. At point D, the pressure will be lowest. क्योंकि इसके राइट वाले जो पार्टिकल्स है वो राइट पे जा रहे हैं, लेफ्ट वाले पार्टिकल लेफ्ट पे जा रहे हैं, वहां पर कोई भी नहीं. ठीक है, as in you have lesser number of particles there. So particles are furthest away from this point. And the answer therefore is D. Read question number 24. Give me a second. Okay, going over 23 again, since there's some confusion here. How do you know the direction of the arrows? Because the question says displacement to the right or displacement to the left. So this is a room, and this is the distance from the left hand of the room. So if I were to draw this room, this is where it is. This is how it looks like. So this point is 0 displacement. So you have particles here. And at A, the particles are moving to the right. This is A. At B, the particles are at their positions. And at C, the particles are moving to the left. So point B is actually a compression point. The reason behind that is you've got particles from A coming to that point, and you've got particles from C also coming to that point. So that's a compression point. On the contrary, if you were to talk about point D, this is point D. So to the right, particles are moving to the right. To the left, particles are moving to the left. So the particles are moving away. So point B is actually a point of compression, and point D is actually a point of rarefaction. Question number 24 says, a source emits a sound wave of a single frequency. The Doppler effect causes a different frequency of sound to be heard by a stationary observer. What is the requirement for a Doppler effect to occur? So the requirement for Doppler effect is that the source that is moving as it produces the sound wave. Yes, the source needs to move while it's producing the sound wave because the observer is stationary. A source that produces a polarized sound wave, no. A source that produces a sound wave of changing amplitude, this is not a requirement. A source that produces a sound wave of changing frequency, no. Even if the frequency is constant, you still observe Doppler effect. So the answer is A. Question number 25 says, an electromagnetic wave in free space has a frequency of 2.5 into 10 to the power 14 Hertz. Which region of the electromagnetic spectrum includes this frequency? So for this question, you need to know the frequencies of each part of the electromagnetic spectrum. And infrared lies in this frequency, 2.5 into 10 to the power 14. Microwave is approximately 10 to the power 10. Ultraviolet is approximately 10 to the power 15. And X-ray is high frequency 10 to the power 18. Ten to the power 10. Question number 26 says, two polarizing filters are placed next to each other so that their planes are parallel. The first polarizing filter has its transmission axis at an angle of 50 degrees to the vertical. So we have our vertical wave, and let's say this is our wave. Let's see the front view. And our transmission axis is at an angle of 50 degrees. 50 degrees. The second polarizing filter has its transmission axis at an angle of 20 degrees to the vertical. The angle between the transmission axis of the two polarizing filters is 30 degrees. A beam of vertically polarized light of intensity 8 watts per meter is incident normally on the first polarizing filters. What is the intensity of light that is transmitted from the second polarizing filter? So for the light incident on the first polarizing filter has an intensity of 8 watt per meter squared as shown here. After light passes through this, I know the intensity will be I naught cos squared theta. So I can say intensity is 8 multiplied by cos squared theta, where theta is equals to 50 degrees, cos squared 50. So after passing through the first filter, our light will be polarized in this direction, in the direction of this filter. And then when you talk about the second polarizing filter, the second polarizing filter is placed at an angle of 20 degrees to the vertical. But it has an angle of 30 degrees to the previous one. अगर उसका पिछले वाले पोलराइजिंग फिल्टर से 30 डिग्रीज का एंगल है, तो अब जो ये लाइट है जो कि पहले पोलराइजिंग फिल्टर से निकल चुकी है, उससे भी किस एंगल पे होगा? 30 डिग्रीज पे होगा. So now I can say that after passing through this, it passes through a filter that is at an angle of 30 degrees. So intensity is equals to 8 into cos squared 50. And whatever the answer is, multiply that by cos squared 30. And that gives you the answer of as 2.5 watts per meters. 2.5 watts per meters. So the answer to 26 is B. Sorry. And to explain this again, I'll use this demonstration. So let's say this white pencil here, the Apple pencil here is our light. So light is initially incident onto this first filter, and this first filter is at an angle of 50 degrees. So for that reason, I used initial intensity, which is 8, and it's incident on the second light, on this filter, the first filter, which is at an angle of 50 degrees, so cos squared 50. After light passes through this first filter, this light will obviously get polarized in the direction of the filter. So light is now in this direction. And the question says our second polarizing filter is at an angle of 20 degrees to the vertical, but it has an angle of 30 degrees here between. 30 degrees between the first polarizing filter and the second one. So that is why we use cos squared 30, because now our light is at an angle of 30 degrees to the polarizing filter. So 8 into cos squared 50 into cos squared 30, that gives you 2.5 watt per meter squared. Question number 27 says, so would the answer be the same if the first filter was 20 degrees and the second filter was 50 degrees? Yes. As long as they have 30 degrees in between. A stationary wave on a stretched spring is set up between between 2 points P and T. Which statement about the stationary wave is correct? Point R is at a node. Is point R a node? No, point R is an antinode. So this is incorrect. Point Q and S vibrate in phase. So we know for a fact that alternating loops are in phase. So this loop and this loop are in phase. And this loop and this loop, these are 180 degrees out of phase. They're completely out of phase. So this is correct. The distance between P and T is 3 wavelengths. From this point to this point, this is 1.5 wavelength. Node to node is half, node to the second node is half, and then half. So you have 3 halves which lead to 1.5 wavelength. The wave transfers energy. It's a stationary wave. It does not transfer energy. D is hence also incorrect. Answer आपका है B. Question number 28 says, a bar vibrates with frequency F to produce water waves in a ripple tank. The waves pass through a gap of width X in a barrier so that diffraction occurs. Which combination of vibration, frequency, and gap width will produce the smallest angle of diffraction? Sahi. So, number one, आपकी वेवलेंथ जितनी ज्यादा होगी, सॉरी आपकी वेवलेंथ जितनी कम होगी और आपका गैप जितना ज्यादा होगा, that would produce the least amount of diffraction. So if you have a gap like this and a wavelength of this one, that would produce the least amount of diffraction. Right? So you need for diffraction to be least smallest angle of diffraction, the wavelength should be lowest, which means that the frequency should be highest. And X should be greatest. So maximum frequency and the maximum gap width. That is option D. If you look at option B and option C, the effect cancels out. You're halving one, doubling the other, the effect is cancelled. 29. An outdoor concert has 2 large speakers beside the stage for broadcasting music. In order to test the speakers, they're made to emit sounds of the same wavelength and the same amplitude. The curved lines in the diagram represent wave fronts. Where is the loudest sound heard? The loudest sound would be heard where the crest meets the crest or the trough meets the trough, where you'll get constructive interference. So at A, crest meets trough, incorrect. At B, crest meets trough. At C, something meets something, but definitely not crest, crest, or trough, trough. At D, on the other hand, you have the crest of this wave meeting the crest of the other wave. And that would obviously result in constructive interference, which would lead to the loudest sound heard. Zero sound kahan hoga? Zero sound A pe hoga. Zero sound B pe hoga. A and B would have no sound. In an ideal case, A and B would be zero sound. Clear? C pe you would hear something in between, not the highest, not the lowest. Okay? If I were to draw the wave fronts, let's say loudest sound. So this would be the loudest sound, number 1. And then this would be your loudest sound. This would also be your loudest sound. This would also be your loudest sound. And the simple reason behind that is crest meets crest, somewhere along this line. In between the two, you'll have destructive interference and hence zero sound. So the answer is D. The equation lambda is equal to d sine theta upon n is used to calculate the wavelength of light in an experiment that uses a diffraction grating. The light from the diffraction grating is displayed on a screen. What do the symbols N and D represent? So what is N? N is simply the order number. So the order of the intensity maxima, that is N. What is D? D is basically the distance between the grating, the slits in the grating. So distance between adjacent slits in the grating. So if you have this diffraction grating, the distance between two of these slits is T. So the answer is C. Moving on to question number 31. 31 says the diagram shows a metal block. The block has sides of length A and B and C as shown, and its volume is V. Each charge carrier has a charge of minus Q, and the number density of the charge carrier in the metal is N. It takes each charge carrier an average time of T to pass through the block. What is an expression for the current I? So generally speaking, the formula is I is equals to N A V Q. In any order, doesn't make a difference. Where this V is a lowercase v which represents velocity. So just by looking at the units, you can realize that you will come to the conclusion that some of these are incorrect. But if I were to solve this properly so that I come to an answer instead of using elimination, what is A? A is the cross-sectional area. What area are they talking about? This is the area. C. C multiplied by A. So I can say N multiplied by C multiplied by A, lowercase a. What is this V? V is the drift speed. Speed is distance, which is B upon time, distance upon time. Hence B upon T multiplied by charge. Now my question to all of you guys is, what is A into B into C? What is A into B into C? What does that give us? Length into breadth into height gives you volume. So I can say I is equals to N multiplied by volume, this is charge. N multiplied by volume multiplied by charge divided by time. So N multiplied by volume multiplied by charge divided by time. Why not area is equals to C into B? The area that you consider is always the area through which the current enters. So current enters from this side. This is the area that you'll consider. This is A, this is C. Clear, Azmir? Moving on to question number 32. The circuit diagram shows two lamps X and Y, each connected to a cell. The current in the lamp X is 0.5 amperes and its resistance is 9.6 ohms. The current in lamp Y is 3 amperes and its resistance is 1.2 ohms. What is the ratio of the power in lamp X to the power in lamp Y? So the formula for power is I squared R. So you need to use I squared R for both. For lamp X, the current is 0.5 squared. The resistance is 9.6. For lamp Y, the current is 3 squared and the resistance is 1.2. And that gives you the answer as 0.222, which is option A. So the formula that we used is I squared R. The reason behind that is the current is given, the resistance is given. That is question 32. Question number 33 says the intensity of an LDR is increased. So you increase the intensity of LDR, the resistance of the LDR decreases. The light intensity increases, the resistance decreases. The temperature of a thermistor is increased, the resistance decreases. The current in the component is maintained at a constant value. So even though the current in the LDR is same, even though the current in the thermistor is same, but the resistance has decreased. What happens to the potential difference across each component? So the formula for potential difference is V is equals to IR. For both the cases, the current is constant, but the resistance decreases. So obviously for both, the potential difference decreases. So the answer is D. Question 34 says, an iron wire has a length of 8 meters and diameter of 0.5 millimeters. The wire has a resistance R. A second iron wire has a length of 2 meters and a diameter of 1 millimeters. So my first question to you is, when the diameter is doubled, what happens to the area? So the diameter is doubled. What happens to the area? Does the area get doubled? Does the area get halved? The area increases for sure. How much? By how much does the area increase? Yes. The area increases by a factor of 4. And the reason behind that is that the formula is pi r squared. So you've got a squared sign there. So when the radius doubles, when the diameter doubles, the area becomes 4 times. When the radius is tripled, the area becomes 9 times. When the radius is quadrupled 4 times, the area becomes 16 times. So that is the ratio. Now, you can either use the lengthy approach to this, work everything out, or you can just use R is equals to rho L upon A. So the resistance of this initial wire was R. So let's say start with R. For the second one, the length is 1/4. Because the length is 1/4 and the resistance is directly proportional to length, the resistance also becomes 1/4. For the second wire, if you just take the length into account, the resistance will be 1/4. Okay. The area is 4 times and resistance is inversely proportional to area. So if you increase the area, the resistance decrease. You increase the area by 4, the resistance decreases by 4 and the resistance decreases by 4. So now we've taken both these factors into account and I know that the resistance will be down by a factor of 16. So the answer is R upon 16. I believe this was the easier approach to it. Question 35 says, a cell with a constant EMF is connected across a fixed resistor. Over time, this internal resistance of the cell increases. Which change occurs as the internal resistance of the cell increases? A decrease in the charge of each charge carrier. The charge of a charge carrier is unaffected. The charge on a charge carrier is 1.6 into 10 to the power minus 19 coulomb because it's an electron. That does not change in any case. So no. A decrease in the potential difference measured across the cell. Yes. If the internal resistance increases, the drop inside the cell increases. There's more lost volts, There's more energy lost inside. So the potential difference across the cell will decrease. The cell will give less terminal potential difference. ठीक है, अंदर ज्यादा ड्रॉप आ रहा है क्योंकि अंदर रेजिस्टेंस बढ़ गई है, तो बाहर कितना मिलेगा? कम मिलेगा. B is the correct answer. An increase in the energy dissipated per unit time in the fixed resistor. No. क्योंकि अब फिक्स रेजिस्टर को वोल्टेज ही कम मिलेगा तो फिक्स रेजिस्टर के जो एनर्जी डिसिपेट करेगा वो कम हो जाएगी, बिकॉज द फिक्स रेजिस्टर गेट्स लेस वोल्टेज. EMF is independent of internal resistance. Yes, EMF stays constant. An increase in the number of charge carriers leaving the cell per unit time. So the number of charge carriers per unit is leaving the cell per unit time would obviously, it is obviously, they're obviously relating that to current. जितने ज्यादा चार्ज कैरियर्स पर यूनिट टाइम होंगे उतना ज्यादा करंट होगा, लेकिन हमें पता है करंट क्या होगा, करंट कम हो जाएगा. सही. I'll draw a circuit. So this is our external resistor, this is our internal resistor, this is the EMF, and this is the capital R. Isn't it the terminal potential difference that it should decrease? So this is the terminal potential difference, ना? सही. तो let's say आपके पास जो सेल है उसका EMF है 10 volts. पहले अंदर ड्रॉप आ रहा था 2 volts का. तो इसके टर्मिनल पे जो वोल्टेज आ रहा होगा वो वोल्टेज क्या होगा, 8 volts होगा. सही. बट अगर ये अंदर रेजिस्टेंस बढ़ जाती है तो अंदर ड्रॉप भी बढ़ जाएगा. लेट्स से 2 वोल्ट से ये ड्रॉप बढ़ के 3 वोल्ट्स हो गया, तो इसके जो टर्मिनल्स पे वोल्टेज आ रहा है वो कम हो जाएगा ना, डिक्रीज हो जाएगा, व्हिच इज आल्सो नोन एज द टर्मिनल पोटेंशियल डिफरेंस. दिस विल डिक्रीज टू 7 volts. D says an increase in the number of charge carriers leaving the cell per unit time. I'll explain this again. Charge carriers per unit time is obviously linked to current. It's not exactly current, but it's linked to current. जितने ज्यादा charge carriers per unit time होगा उतना ज्यादा charge per unit time होगा. सही. लेकिन हमें पता है जब रेजिस्टेंस बढ़ जाएगी तो टोटल रेजिस्टेंस बढ़ने से करंट क्या हो जाएगा, कम हो जाएगा. So this is incorrect. 36 says Kirchhoff's first and second laws are consequences of conservation of different quantities. What are these quantities? So Kirchhoff's first law is Kirchhoff's current law, and Kirchhoff's second law is Kirchhoff's voltage law. Current law follows conservation of charge, and voltage law follows conservation of energy. Current law states that current entering is equal to current leaving. And voltage law says in a closed loop, the total EMF is equal to the sum of the potential drops in that loop. Question number 37 says a potentiometer circuit is used to determine the EMF EX of a cell. The circuit includes a cell of known EMF E0 and negligible internal resistance and a uniform resistance via PQ of known length. EX is less than cell E0. So EX is less than E0. And you need to determine the EMF of cell EX. The movable connection J can be positioned anywhere along the length of the wire. Which circuit is suitable for determining EX? Number one, because you want to determine EX, your galvanometer is always connected to EX, your unknown cell. So my galvanometer should be connected to EX, hence B is incorrect, hence C is incorrect, either A or D. The second thing is that when you have a potentiometer circuit, both the cells, both the batteries should have their terminals, the same terminals on the same side. तो अगर एक का पॉजिटिव टर्मिनल लेफ्ट पे है तो दूसरे का भी पॉजिटिव टर्मिनल लेफ्ट पे होगा, एक का नेगेटिव राइट लेफ्ट पे है तो दूसरे का भी नेगेटिव लेफ्ट पे होगा. सही. और I can say that the identical terminals should be connected together in one way. So if you have positive over here, this positive and this negative, this is incorrect. D is the correct answer. Negative on this side, negative on this side. Galvanometer connected to the unknown smaller EMF. And then you have this junction and everything. Question 38 says, in an experiment on alpha particle scattering, alpha particles are directed at a thin gold foil. Most of the alpha particles pass straight through the foils, are deflected by a small angle. A small number of alpha particles are deflected by a large angle. Which statement cannot be deduced from this experiment? Atoms are mostly empty spaces. This can be deduced. This is one of the conclusions. Most of the mass of an atom is concentrated in the nucleus. This can be deduced. The nucleus of an atom contains protons. No, that is not a deduction. The nucleus of an atom is small compared to the size of an atom. Yes, just by comparing the number of particles, the alpha particles passing straight through undeviated and the number of particles being deflected, you can come to the conclusion that the nucleus is small as compared to the atom. So this is also correct. And they're asking which one cannot be deduced. It's C. Question number 39 says 4 nuclei are represented below. Which statement about these nuclei is correct? An uncharged atom of nucleus of element Q has 24 orbital electron. No. Element Q has 13 protons, hence 13 electrons. Nuclei G and M are isotopes of the same element. G and M don't have the same proton number, so they cannot be isotopes of the same element. Even though they have the same nucleon number, but that is not the condition. When E absorbs a neutron and then emits an alpha particle, E transforms into M. Let's see. So E 2814. So E absorbs a neutron. A neutron is 0, 1. And then they want it to give out an alpha particle where alpha is 4, 2. And they're saying that it should give you M. M is 25 and 12. So if you were to look at the left, neutron is 10. Neutron is 1, 0. Yeah. Sorry, the other way around. My bad. Neutron is 1, 0. The proton number is 0 and the nucleon number is 1. This is the correct one. That was for proton. This is for proton. So 28 plus 1 is equals to 29. 25 plus 4 is equals to 29. So this is balanced so far. So this equation looks correct up till this point. 14 plus 0. 2 plus 12. Both give you 14. Which means that this is absolutely right. If E were to absorb a neutron and give out an alpha particle, it would definitely give you M. Part D says, option D says, when M emits a beta minus particle, M transforms into Q. No. For a beta emission, the nucleon number never changes. And because the nucleon number is changing, I know this cannot be due to a beta emission. The last question says, a neutron is composed of 1 up quark and 2 down quarks. When a neutron decays to a proton, a beta particle is emitted. So a neutron decays to a proton, which means up, down, down converts to up, up, down. So if I were to compare the two, I can clearly see I've got this up present here. I've got this down present here. One down converts into an up. So my equation becomes a down quark converts into an up quark. A down quark converts into an up quark. Has to be either A or B. Gives out a beta minus particle. And whenever you have a beta minus particle, an electron being emitted out, you always get an anti-neutrino. So the answer is B. In case of a beta plus emission, you will always get an electron neutrino as opposed to an anti-neutrino. So the answer to this one is B.